professors. Today, my work team and I are going to expose about a new way to calculate the capital asset pricing model. In this occasion is with drawdown measures. Well, to introduce the entire paper, we're going to explain a little bit what is the capital asset pricing model. Well, it's a very important and fundamental concept in the modern finance. It's used to calculate stock returns, so you can know the price of an action, for example. So that's something you can introduce it. Well, it's a single factor in a linear model, so you can see that the Capm it's equal to the risk-free rate more a beta plus the excess market returns. Well, the slope here in this linear model is it's called an asset beta, and this is a factor that you calculate with optimal portfolio market portfolio and returns of stock returns from an asset using the standard deviation and the variance. Well, why the writers want to, what was the motivation for them? What does the investors want? Well, for the investors, it's not only matter about how much I lost or how much I earn. They care about the sequence of times. They care about the sequential structure of returns. They want to know how much I will be earning or losing in the next summer, something like that. How do we incorporate the drawdown measures in the classical Capm, the capital asset pricing model? Well, first we're going to make a comparison between the classical Capm and the Capm with drawdown measures. The first one can only be calculated in one period. The second one can be calculated with sequential periods. You can include a lot of financial instruments. You can add more database, so you can add more factors. And the principal difference is that in the classical Capm you have a beta calculated with the relation between the standard deviation and the variance. And in the Capm with drawdown measures, the beta calculated is based on the historical drawdowns. Well, now my friend is going to explain. No, sorry. Well, I'm going to explain you like the goals of the work of the paper. Well, the first one is to define a drawdown beta and to demonstrate empirically that it's an informative measure of an asset performance for hedging against market drawdowns. For example, if you have a market that's going down, you want to know what's going to happen with your asset. Well, the second goal is to lay down a theoretical foundation for the beta drawdown, for the drawdown beta through the portfolio theory.
Good afternoon. Following the presentation, I'm going to explain the model. The basis of this model is established through the drawdown. The drawdown is a measure of reverse that mathematically is expressed the maximum of W sub k minus W sub t, where W sub k is the cumulative returns of instrument that we have, and W sub t in a period k, and W sub t is the cumulative return of instrument used in the consecutive period t, in this interval of time. Also, the drawdown can be expressed like a maximal drawdown, an average drawdown, and conditional drawdown. So to understand better, I'm going to explain an example. Next. We have this spreadsheet. We need to calculate the drawdown to period 5. So we need the maximal drawdown of this period, and we need the cumulative return for period 5. So the max is 1.5%. Is the maximal cumulative return of this period of time. In the x-axis is the period of time, and the y-axis is the return, between 0 to 1.5%. And we need the cumulative return to period 5. So this is 0.5%. So the drawdown is 1.5% minus 0.5. So the drawdown is 1% in this example. So the drawdown on the CAPM. How do we incorporate the drawdown in the CAPM? Next. Oh. Well, the drawdown allows us to incorporate additional information to understand the return asset hitting against the market drawdown. So the drawdown is incorporated with the beta. This is the drawdown beta, and in the numerator is expressed the average multiple drawdown for overtime, for all time, all periods. And in the denominator is the drawdown for optimal portfolio.
Well, discussion. But for each hedge fund index, forebears are evaluated depending on the confidence level alpha. So this is obtained to calculate the difference bear for different scenarios. Different scenarios. According to the risk level, where we have here the four betas. Average beta with alpha equal 0, CDR beta with alpha equal 0.9, and max beta with an alpha equal 1. And the classic beta of CAPM, that is the standard beta. Well, an example, at the first C&P 500 like optimal was taken to use like an optimal market portfolio. So that's used to calculate different beta. So from different beta and from different scenarios, and the database from each FRX is used to compare the S&P 500 with another database with 80 dates. Well, we can see here the figures. Then we can compare the S&P 500 portfolio, what is the optimal portfolio, with our data that is an example for the market. So we can see here that our data is going up, while S&P 500 is going down. So the time is from January 2005 to June 2012, and we can see the S&P 500 lost 70.28%, which is the maximum drawdown, and during the same period our data 76.39%. So with that data, we can have a result of max BD beta with an alpha equal 1 for our data, and is given by the following expression, and that you can see there as the BDD of drawdown, and the result is minus 1.09. So in this case, we're going to calculate the CDR beta. So you can see the same the same figures, but we are going to pick the two largest drawdown from October 2007 to February 2009, and from October 2007 to March 2009. S&P 500 index lost 70.28% and 61.74% respectively. So during the same period, our order portfolio earned 76.39% and 82.37% respectively. So we can calculate the CDR beta for our order with an alpha equal to 0.978.
Thank you,
Is
sir.
given by
Go to the conclusion.
Okay, well, to conclude all the paper, we can say that it was possible to formulate a CAPM for a portfolio problem with CDR measure. It was possible. Well, now we can see that a CDR beta and a CDR alpha can be used to prioritize financial instruments that can hedge against market. That's why I was telling you that you can cover yourself with hedge against the market drawdowns with a good CDR beta. Well, and this you can see this with an HFRX database that has shown difference between classical beta and CDR beta. What I want to tell you with this is if you have a classical beta with a positive value, you can have a CDR beta with negative value. And this is useful because you know that you can have a hedge against market drawdowns.
Thank you.
All very clear.
Yes, I understood. Actually, it's the first presentation that I actually understand. So, very good, thank you. I want to ask you something.
Yeah.
I mean, this is not a question, this is a recommendation.
Yeah.
You speak very well English, so try to speak slower.
Yeah.
Okay? I know that you're nervous, but you're like, and something.
Yeah, it's because all the time.
I
We
know,
have
I
10
know.
minutes and I want to
Sometimes
do
you
it
use
very fast.
some words, but it was perfect. And I want to ask you some other thing. Where did you learn English?
And my school, all the teachers were so.
I knew it. I knew because
And
that
it's
is,
easy to-
that's not-
Harry Potter.
yeah, he talked like this. It's
Yeah,
not,
but
it's not
did you
the
understand what I
American
said?
accent.
Did you
It's
understand
a-
what I say?
It's a different accent. You
Yeah.
have a very good accent. So congratulations, the three of you. I really enjoyed this presentation. Thank
Okay,
you.
thank you very much.